Hi guys, I thought I'd do a quick video for you guys and just go over our lesson from today. So I've got a scenario here, very similar to what we were doing today, practically outside the classroom. So this is in relation to what we call the mirror method, aka similar triangles. So what we've got here is a building. Okay, that's the very top of the building. Forget the gutter or whatever, just the very top of the building. I've got a scenario here where there's a mirror. Okay. And we've got a bloke here, or a student who's, walked, um, who's placed the mirror here perfectly. So he has been very clever. I don't know about you, but I do think this particular boy is very clever. I don't know what your thoughts are on this. But anyway, he's put a distance from here to here, and he's been pretty smart about it. He's put a distance of, I think, 6 meters. So I'm going to go exactly 6 meters. I wonder why. Why not like randomly just put the mirror somewhere? Well, actually, you can. The maths will flow. But hey, just for simplicity and easier calculations and nice whole numbers, stick to whole numbers. You choose where you want the mirror to be. So what I'm going to do is quickly go and insert an arrow. I should have done this properly, but that's all right. Now, I recommend you choose the middle of the mirror, not the front edge or the back edge, because the mirror does have a distance from the top to bottom. A few centimeters does make a difference. So this here is 6 meters. So can I change? Um, just make it a bit thicker. Maybe change the color there. Insert a text box. Sorry, I'm a bit slow on this. So that distance there, um, is 6 meters. Happy to make that a bit larger, maybe. Cool, 6 meters. Um, outline, no outline. 6 meters. There we go. Cool. Now, Mr. Student here, the lovely student here, he does not know exactly how far he has to walk back. He just has to keep walking back from the mirror till he can see that very top edge right in the middle of the mirror. Okay. After he does that, he's going to get a friend to come and measure this distance from the middle to his. We went with heels, so we'll stick to heels. So I'm going to go control C, just that distance there. Now my diagram is not to scale, so don't get worked up thinking, "Hey, Mr. K, you drew a funny diagram. I don't understand. It's not proportional. It's just a rough sketch." Now you keep doing this till you see the mirror. Of course, now it just so happens to be. Let's say we get Brendan who comes in, and he goes, "I'll measure the distance here for the student, and it comes out to be 1.8 meters." Okay, 1.8 meters. So given the fact that you can see the top of the building in that mirror, and in theory, if there was someone standing or just lying on the roof here, not that it's safe practice, but like a bird or something, and if the bird look right in the mirror, guess what the bird will see? This particular student. Okay, they'll see Bart Simpson. So proportional. In other words, similar triangles. So that side is proportional to that. Now, the point of doing this exercise is, of course, to calculate the height of this building. Now, by now, you would have figured out where your right angle triangles are. There's one here. There's a 90-degree angle, but maybe I'll insert a right angle triangle. Can I do a triangle? Triangle. Where are they? There. So from the very top, stretch this thing out. There. Okay, I'm just going to change the outline to that. So that's our right angle triangle here. That's 6 meters, of course. And there'll be another one on this side where Mr. Simpson. Now, we also have to calculate the height. Okay, the height from your eye level to your heel. Okay, staying perfectly straight. So get a friend to do that for you, a nice, reliable friend. And if your friend doesn't know how to do it, hey, teach each other. Teach each other, please. Let's go insert. Maybe I'll just lock that bar. Shape. Uh, cool. Can I do it this way? Okay. Um, I'm sure I can rotate this shape. Can I not? Okay. Control Z. I don't want to waste time because I only have a 9 or 10-minute video limit. I'm using this free software. Can I use that? No. Okay. Sorry, folks. Technical glitch. Insert shapes. I'm sure someone in class by now would be like, "Sir, use this. We know how to do this." I'm like, "Okay, smarty pants." I don't want to fluff around. I'm sure this should work. Well, actually, this should work. Okay. So if I went Control C, shape, look smart, shall we? I should just put that there for a second. Make that shape a bit smaller. Come back here and rotate till we get a right angle triangle. So I've got to hide this gentleman's face for a second, but you kind of figure out what's going on there, okay? They excuse the dotted line. I think it's moved. If it hasn't moved, don't get too worked about it. So there we go. We've got two right angle triangles. They're meant to be similar. We also need a height. We need Bart Simpson's height. So I don't know how tall he is. Don't ask me. I'm just going to randomly make this up. So I'm just going to say this bloke here is 1.7 meters in height. That's only from here to his idol. Must be a really tall boy. Anyway, so there we have it. Now all we need to do is figure out how we're going to calculate that height of the building. Now don't look at my diagram and start saying, "Oh, this side doesn't look this." It's just a rough sketch, if you could say that. So in the classroom, we learn something. What we got to do is find something called a multiplier, right? And the rule for finding the multiplier is take a proportional side and divide by the other. And the rule was take the larger one, divide by the smaller one. If we do it the other way around, we get decimal, which really isn't really pleasant. So it'll be 6 meters divided by 1.8. So I'll get my calculator out. Done some calculations already. So I'll go 6 meters divided by 1.8. Now I'm not going to type it all out here because I think I'm going to run out of video time. So this is our multiplier, 3.333. Now, what do I do with this? Well, you take the multiplier 3.333. Now you will multiply with 1.7 because in theory, this is a ratio. So that ratio there, when it multiplies to 1.7, it'll give you that answer, the height. Bingo. So let's take 3. Do we take the whole long answer? One decimal place. Well, the only one decimal place rounding is the very end answer. So work smart. Do this. Just press time straight away. Your calculator is pretty smart actually. So it'll pick up ANS answer, which is the previous answer, and now you just multiply by 1.7. It's similar to your FX82 calculators. And there we have it. We've just worked out the height of the building, 5.666 recurring meters. So all I got to do is go and write down a little statement here saying calculations. Right from there, I'm just going to write down something of the nature of height of this building is now one decimal place. Now the number after 6, the second decimal place, happens to be 6. If it's 5, 6, 7, 8, 9, delete the whole thing and add 1 to the previous. So that becomes 5.7 meters. Ta-da! So that's really what we call the mirror method using similar triangle theory. Okay, cool. So hopefully that made sense. Now, I hope I've got some time left. If not, I'll do another video. Now, let's say we've got the same scenario. I'm just gonna control A. Oh, control C. Okay, cool. Just gonna put a new window, control V, but this time I'm gonna delete this triangle. Let's say we'll remove the mirror now. Stand where you're standing. That's the trick. Do not move. Stand where you're standing. Now, I've just got a sign saying I'm gonna run out of video space, so I'll do a new one for you guys.